জাস্ট হ্যাঁ এসছে বলে দিই।
Okay, good afternoon all of you. In today's session of waves, the next session of waves, today we are going to have a session on speed of sound in different media. Today's session is going to be on that. So the important thing regarding speed of sound in any medium is that it is proportional to the square root of elasticity, and it is inversely proportional to the square root of density. So you know that among solids, liquids and gases, the most elastic is solids and the least elastic is gases. And you know that as far as density is concerned, the maximum density is of solids and the least density is of gases. So if you look at this formula, root over elasticity modulus by density, if you look at this formula, then looking at this formula, it seems that solids have highest of both. They have highest elasticity and highest density. So then how does the comparison happen between solids, liquids and gas? So it was found that the elasticity of solids is so high that it sort of compensates for the high density of solids compared to liquids and gases. So the overall calculation of elasticity by density is maximum for solids, second liquids and third gases. So speed of sound is highest in solids, second liquids, and speed of sound is least in gases. So for solids it is root over of Young's modulus by density. Okay, next we come to liquids. So for liquids, the speed of sound is root over bulk modulus by density, because speed of sound is proportional to root over of elasticity and inversely proportional to square root of density. So for liquids, it is bulk modulus by density for liquids. Now regarding the speed of sound in gases, actually Newton said that propagation of sound in gases is isothermal. According to Newton, the propagation of sound through a gas is isothermal. So according to Newton, the formula that we should use, it should be isothermal formula. So root over pressure by density. So Newton suggested that we should use this formula root over pressure by density. But later on there was another scientist called Laplace, and he said that no, propagation of sound in a gas is adiabatic, it is not isothermal. So Laplace suggested that this formula, there has to be a multiplier gamma in the numerator. Gamma, all of you know, is adiabatic exponent Cp by Cv. So Laplace said that instead of pressure you should have gamma into pressure, and after certain experiments were done and the speed of sound was found, it was found to be closer to the one given by Laplace than the one given by Newton. So we take speed of sound in a gas as root over gamma into pressure by density. Now this formula root over gamma into pressure by density, this formula root over gamma into pressure by density, we can also write root over gamma into R into T by M. So gamma remains, as you know, gamma, and then R is the gas constant, T is the Kelvin temperature, and M is the molar mass of the gas. So instead of root over gamma into pressure by density, we can use root over gamma into R into Kelvin temperature by molar mass. So these are the different formulas for speed of sound in solids, liquids and gases. Okay, now I am giving you some homework based on this topic. So I am giving you some homework based on this topic. So at STP 273 Kelvin 10 to the power 5 Pascal, the mass of 22.4 liters of O2 is 32 grams, and CV is 2.5 hours, CP is 3.5 hours. Okay. So at STP 273 Kelvin 10 to the power 5 Pascal, mass of 22.4 liters O2 is 32 grams, CV is 2.5 hours, CP is 3.5 hours. The question is, what is the speed of sound in oxygen? What is the speed of sound in oxygen? Okay. So this is the first homework question. Okay, question number 2. Question number 2, at 17 degrees Celsius, the speed of sound in some conditions like air, atmosphere, whatever. At 17 degrees Celsius, it is 340 meter per second. So at 32 degrees Celsius, what will be the speed of sound? This is question number 2. Okay, question number 3. At a certain temperature T, the speed of sound is double of the speed at 0 degrees Celsius. At a certain temperature T, the speed of sound is coming double of what it is at 0 degrees Celsius. The question is that what is the temperature T? Okay, you have to identify the question temperature T. Okay, question number 4. There is a particular region in space where at one place the temperature is 280 Kelvin, at another place the temperature is 310 Kelvin. So there is a region in space, one place it is 280 Kelvin, another place it is 310 Kelvin, and between these two the gap is 33 meter. So the question is that, and it is given that speed of sound in air at 273 Kelvin is 330 meter per second. So once again, there is a certain region in space where the two ends have temperature 280 and 310. The gap between them is 33 meter, and the speed of sound at 273 Kelvin is 330 meter per second. Using this data, you have to find the time taken. You have to find the time taken, like how much time the sound will take to go from here to here. You will have to find the time taken. That is question number 4. Okay, and the last homework question, question number 5. The gamma value for oxygen and hydrogen both are 1.4. The value of gamma for O2 and H2 both are 1.4. And the speed of sound in oxygen is 470 meter per second. The question is, what is the speed of sound in hydrogen? And it is given that they both are at the same temperature and pressure. So gamma for O2 and H2 both is 1.4. Speed of sound in oxygen is 470. What is the speed of sound in hydrogen? And both oxygen and hydrogen are at the same temperature and pressure. So these are the 5 homework sums. The next session will be on Monday. Tomorrow there won't be any session. So you'll have to submit this homework anytime before 9 p.m. of Monday. So I'll end this session now. Thanks a lot. I'll conclude now. Bye all of you.